Hello, and welcome to Echoes of the Forgotten Earth, a quiet place where curiosity lingers and science is allowed to take its time. Tonight, we won't be diving into the birth of the universe or the fate of distant galaxies. Instead, we're turning our gaze downward toward the ground beneath us to ask something simple yet profoundly unsettling. What if we're not the first? Not the first minds to wonder, not the first hands to build, not the first beings to explore. What if, long before pyramids, satellites, and late-night science shows, another civilization walked this same planet, rose to complexity, and then vanished? I'm not talking about lost continents or alien visitors. I mean a civilization born of Earth itself, biological, intelligent, and perhaps so different in nature that even the planet has forgotten it. It sounds like the premise of a science fiction novel, and in part it is, but it's also a genuine scientific question. For years, geologists and astrophysicists have quietly asked it in conference halls and research papers. If there had once been an advanced civilization on Earth millions of years ago, would we even be able to tell? Would its traces survive the slow, grinding churn of the planet? Or would everything, its cities, tools, language, even its bones be recycled into rock and dust, indistinguishable from nature itself? Before we peel back the layers of time, I'd love to know where you're listening from and what time it is there. It's funny, isn't it? We're talking about ancient civilizations, yet here we are, separated by distance and seconds, sharing the same quiet moment. Wherever or whenever you are, I'm glad you're here. If questions like this are your kind of company, I'd be grateful if you stayed a while, liked, subscribed, or simply listened. It helps this little signal of curiosity reach others like you. No pressure, just an invitation, like a faint trail of footprints that might, if we follow carefully, lead somewhere unexpected. So settle in. Lie back if you can. Let your thoughts drift to the slow rhythm of tectonic plates. We're about to look not through human history, but through the crust, the silence, and the heat of deep time. Before we can ask whether someone came before us, we must first understand how vast time truly is, and how good this planet is at wiping its own slate clean. When we speak of ancient history, we usually mean a few thousand years. The age of pharaohs, the builders of Stonehenge, the first words pressed into clay. Even the dawn of civilization stretching back 12,000 years is only a blink in geological time. To the planet, it's almost now. And yet, to us, it already feels impossibly distant enough to fill entire libraries with wonder, mystery, and debate. But Earth itself is staggeringly old. Not millions of years, billions. Around 4.5 billion, give or take, a few hundred million. For most of that expanse, there were no humans, no mammals. For ages, there wasn't even life on land. Life's early chapters unfolded in water, microscopic and patient. And in that unseen world, the story of Earth was already being written, layer by layer. Grain by grain. The planet doesn't keep a diary. It forgets quickly, and it doesn't preserve everything equally. Wood rots, metal rusts, bone dissolves. Time doesn't merely pass, it acts. It buries, melts, crushes, and erases. Mountains rise and crumble. Oceans open and close. Continents drift, collide, and fracture. Every few 100 million years, the planet's face transforms completely. So perhaps survival, not loss, is the real miracle. Let's imagine, just as a thought experiment. 100 million years ago, long after dinosaurs ruled but before their end, a species evolved. Something intelligent. Maybe upright, maybe not. Perhaps it lived on land or in the sea. Maybe it never needed to build with stone or steel. Maybe its technology was unrecognizable to us. Biological, ephemeral, or entirely lost to decay. Perhaps it lived, thrived, developed something we might call culture, and then, through disaster or simply time, vanished. And now, Millions of years later, we arrive, digging, speculating, wondering if we'd even know it had existed at all. Here's the uncomfortable truth. We are not as permanent as we imagine. Our skyscrapers, highways, satellites, all the emblems of our age aren't built to endure geological time. Leave a city alone for a few centuries, and nature takes it back. Wait a few thousand years, and only faint outlines remain. Wait a few million, and even those are gone, eroded, buried, subducted into the planet's deep, molten memory. This isn't science fiction. It's what geology and archaeology already tell us. Even evidence of recent prehistory is rare, not because humanity lacked creativity, but because Earth is a ruthless recycler. The fossil record is patchy at best, not due to scarcity of life, but because fossilization is extraordinarily selective. To become a fossil, an organism must be buried quickly, mineralized, shielded from erosion, and then survive the slow violence of time until someone uncovers it. Multiply those odds over tens of millions of years, and you begin to understand the scale of what disappears. And it's not only bones. Buildings crumble, metals corrode, plastics disintegrate, concrete turns to dust. If a civilization had existed deep in the past, one that didn't build stone monuments or leave behind enduring architecture, we might never know it was here. You might be wondering if anyone has ever taken this question seriously. The answer is yes. In 2018, two scientists, NASA climatologist Gavin Schmidt and astrophysicist Adam Frank, published a study that dared to explore this very idea. They weren't claiming that an ancient civilization had existed. Instead, they asked a sharper, more scientific question. If it had existed, how would we even know? They called their thought experiment the Silurian hypothesis, a nod to a fictional species of intelligent reptiles from British science fiction. The name was tongue-in-cheek, but the reasoning was anything but. Their real focus was methodological. What kind of fingerprints would an industrial civilization leave in the geological record after millions of years? Could we detect such traces today? And if we did, would we recognize them for what they are? Rather than looking for crumbling towers or metal artifacts, they turned their attention to the chemistry of the planet itself. Carbon isotope shifts, rare metal anomalies, synthetic molecules that don't occur naturally, changes in sediment composition, the quiet language of deep time. It's the approach of detectives who have no body, no weapon, no witnesses, and must instead read the wallpaper for clues. And in doing so, they touched upon an uncomfortable possibility. Maybe absence isn't proof of nothing. Maybe this is simply how a planet looks after it has erased its own history and started again. Civilizations, after all, do not vanish neatly. They leave waste. They alter chemistry. They rearrange the landscape. But fingerprints fade. So the question becomes, if a civilization long before ours had reached an industrial phase, burning, mining, farming, manufacturing, could we still detect the echo of its impact in the rocks beneath our feet? Maybe. Maybe not. Even now, our own imprint is being written into the geological record. Scientists call it the Anthropocene, a proposed epoch defined by human influence. Plastic woven into ocean sediment, concrete scattered through soil, nitrogen from fertilizers saturating the atmosphere, radioactive isotopes from nuclear tests whispering through the crust. If, millions of years from now, some future species, whoever or whatever it might be, were to dig into the layers of our present, it would find these signals. The only real question is, how long will they last? Will they still be there after continents shift, mountains crumble, and oceans consume the shorelines? Or will they fade until the planet forgets us too? This isn't idle speculation. Thinking this way helps scientists test the limits of their own methods, to understand not just what evidence survives, but what vanishes without a trace. Because the geological record is full of silence. Some eras are preserved in exquisite detail. Others are wiped nearly clean. Erosion can remove layers that took millions of years to form. Tectonic shifts can fold, fault, and bury entire regions, rewriting their history as though it never happened. And then there's the ocean, a vast, shifting archive that hides more than 70% of the Earth's surface beneath miles of water and sediment. Most of that surface is geologically young, reshaped, resurfaced, or recycled within the last few 100 million years. Even the ocean floor, constantly renewed through subduction, has an average age of barely 200 million years. That means nearly every seafloor the Earth has ever had has been erased and replaced many times over. If a civilization once thrived along a coastline, on an island, or within what is now a drowned plain, its traces would likely be gone, dragged downward, melted, and transformed into molten memory. And yet, here we are, building, recording, observing, wondering. We look to the stars and ask if we are alone in the universe, but rarely do we ask if we were ever alone here, on our own planet. Maybe the past was quieter than we imagine. Or maybe we've simply lost the ability to hear it. In a moment, we'll explore what could survive, what couldn't, and whether we might already have stumbled upon traces of something older than ourselves without realizing it. Because this story has more layers, both literal and scientific, and we'll move through them carefully, one at a time. Let's slow down and begin with a simple question. Before we start searching for lost civilizations, we should decide what exactly we mean by civilization. What makes one count, scientifically speaking? In everyday conversation, we often treat civilization as a high-tier version of society, cities, writing, governments, skylines. But that's a narrow, modern perspective. Even across human history, civilizations have worn many faces. Some built monumental cities of stone. Others left almost nothing but patterns of language, trade, or land use. Yet we call them all civilizations. In archaeology and anthropology, the term is more precise. Civilizations are recognized by recurring traits: urban centers, specialized labor, centralized authority, organized religion, surplus agriculture, social hierarchies, symbolic communication, and long-distance trade. Not every civilization checks every box, and some do so in unexpected ways. So when we imagine a civilization far older than humanity, tens of millions of years old, we must broaden our thinking. We shouldn't expect skyscrapers or microchips. We should look instead for signs of complexity, social, technological, or ecological, patterns that don't arise by chance. A civilization isn't a finish line. It's a spectrum. Somewhere between solitary survival and planetary engineering lies a wide range of possibility. A culture of toolmakers that built structures meant to outlive their creators. A species capable of storing knowledge, passing it on, shaping its environment intentionally. That alone would mark a turning point in evolution. And if it happened once, it could have happened before. Let's start with an example closer to home, one that shows how subtle civilization can be. In what is now modern-day Turkey lies the ancient settlement of Çatalhöyük. It's about 9,000 years old, older than most cities, older than writing itself. There were no streets, no temples, no palaces. Houses stood wall to wall, connected like cells in a honeycomb. People entered through the roofs. Fires burned inside. Art decorated the walls. By our modern standards, it might look primitive. Yet to archaeologists, Çatalhöyük is one of the earliest known cities, a symbol of human organization, planning, and continuity. Because what matters isn't scale or architecture, it's pattern. The coordinated rhythm of life shared across generations. When we trace civilization backward through time, the clues become quieter and more fragile. Before stone walls and written words, we find pigments, carvings, and tools. Traces of minds that could imagine, plan, and remember. These artifacts may not look like technology in the modern sense, but they are technological in spirit, evidence of thought made tangible. They show memory, creativity, and purpose, the foundations of any civilization. So imagine now something far older, not 10,000 years old, but 10 million or 100 million. What would its traces look like? It depends entirely on what it was. If it built with organic materials, wood, fiber, bone, those would have vanished long ago. If it buried its dead with ritual but without durable objects, the bones might remain, but the meaning would be lost. If it used symbols we can't recognize as language, its stories might have dissolved into silence. And if it lived in environments that don't preserve fossils, coastal deltas, tropical forests, shallow seas, the odds of finding anything at all become almost zero. Civilizations that thrived in humid jungles, along coasts, or in swamps would leave little behind after only a few centuries, let alone millions of years. It isn't a matter of concealment. It's simply the nature of time. We also have to be cautious about projection. When we think of intelligence, we picture our own reflection: language, cities, machines, digital signals. But there's no rule that says intelligence must look human. A civilization might not be industrial in any recognizable sense. It could organize itself in ways that leave few material traces: chemical communication, environmental engineering, or cooperative behaviors beyond our current imagination. Which raises a haunting question. Would we even recognize it if we saw it? Consider a termite mound. To us, it's a pile of dirt, but to an engineer, it's a masterpiece. An organic skyscraper with air circulation, climate control, and food storage. Millions of individuals working as one, guided by instinct and chemistry, sustaining a collective organism. Scale that up by a factor of 1,000, then bury it under layers of soil for a few million years. Would it still look artificial, or would it be dismissed as just another geological formation? When we search for lost civilizations, we have to think both as archaeologists and as biologists. We're not only looking for ruins, we're looking for patterns, for disturbances in nature's rhythm, places where mineral deposits, sediment layers, or isotope ratios hint that something deliberate once happened. Strange concentrations of metals, unexplained chemical shifts, anomalies that resist natural explanation. These are the faint signatures of agency, the ghostly fingerprints of something that once shaped the world. Then comes another question, one of duration. How long must a civilization exist to leave a lasting mark? Not long, it turns out. Geologically speaking, a few hundred years is enough. Humanity's own industrial age has already altered the planet beyond recognition, a chemical scar that will linger for millennia. We've filled the air with carbon, the soil with nitrogen, and the oceans with plastic. We've scattered radioactive isotopes into rocks that future geologists might one day measure. Even if we disappeared tomorrow, traces of our existence would persist, thin, uneven, but real. A few millimeters of sediment carrying the memory of an age that burned bright and brief. So perhaps the question isn't whether another civilization once existed. Perhaps the question is whether we even know what to look for. We search for fossils, ruins, and tools, because that's what we leave behind. But what if the evidence is stranger, smaller, hidden in forms we haven't learned to interpret? Maybe the planet has already spoken, and we just haven't learned its language yet. To understand this fully, we must look not at artifacts but at Earth itself, at the forces that preserve, destroy, and erase. Because the key to detecting what came before isn't buried in legend or myth. It's buried in time. Earth hides nothing deliberately. It simply moves. It breathes. It forgets. If you wanted to hide something forever, you wouldn't need to bury it deep or burn it to ash. You'd only need to leave it on the surface. And wait. Not days, not decades. Just wait long enough for the planet to do what it does best. Because Earth is not still. It shifts, folds, consumes, and almost everything built upon it, no matter how proud or vast, eventually disappears. We humans rarely notice this. To us, landscapes feel permanent, mountains eternal, rivers fixed, cities seem timeless. But to a geologist, everything moves. Even rock flows, bends and fractures under pressure. Even the tallest peaks crumble, grain by grain. The surface of Earth is not static. It's alive with motion, sculpted by heat, wind, and water. And that means everything resting on it, every city, monument, or footprint, is temporary by default. Let's begin with the simplest sculptor: weathering. Rain, frost, wind, heat. All of it gnaws at exposed surfaces. Cliffs dissolve, roots break stone, metal oxidizes, wood rots. It doesn't take long. A few centuries, and a city becomes ruin. A few millennia, and that ruin becomes dust. Unless preserved under rare conditions, deep freeze, desert, or rapid burial, it's gone in geological terms. Then comes sedimentation, the slow burial of history. Soil, sand, volcanic ash, dust. Each layer hides what came before. Over time, they compress into stone, distorting or destroying what lies beneath. Organic materials vanish, minerals replace them, and what remains becomes faint impressions in rock, if anything at all. Now we come to one of the planet's most powerful sculptors: tectonic activity. The Earth's crust is not a single, solid skin. It's a mosaic of plates floating on a slow-moving sea of molten rock. These plates collide, drift apart, and slide past one another in a slow, relentless ballet. When they meet, mountains rise. When they separate, oceans are born. And when one slips beneath another, it carries the surface down into the deep, erasing everything it once held. This process, known as subduction, is one of nature's most efficient destroyers. It means that entire ocean floors, along with their sediments, fossils, and any record of what existed upon them, are steadily pulled into the mantle and melted away. The average age of the seafloor is only about 200 million years, which might sound ancient until you remember that Earth itself is over 4.5 billion years old. That means the planet has remade its oceans dozens of times. Any civilization that might once have thrived near ancient coasts or islands would now be part of the planet's interior. Their remains turn to magma and memory. Continents last longer, but they too are far from eternal. Erosion eats at them from above. Glaciers grind their surfaces smooth. Volcanoes bury them in ash and lava. Rivers carve them apart and carry their dust to the sea. Even impact craters, scars left by asteroids large enough to change the course of life, can fade with time. What looks immovable to us is only a moment in motion. The Grand Canyon, for example, is often celebrated as one of the planet's great archives. Layers of sediment stacked like the pages of a history book. But even that book has missing chapters. Entire epochs are gone, erased by erosion, never written at all, or overwritten by new layers. Geologists call these gaps unconformities. They are reminders that the Earth's memory is selective, that most of its story is missing. Survival is rare. The fossil record, our best archive of ancient life, is astonishingly incomplete. Most organisms never fossilize, even those that do survive only if the rocks around them endure long enough to be exposed and discovered. It's not that fossils are common and undiscovered. It's that fossils are exceptional, tiny miracles that defied all odds. For every species we found, countless others left no trace at all. If that's true for living creatures, for bones turned to stone, then it's even truer for the fragile works of culture, tools, carvings, buildings, or technology. Even within our own brief history, most artifacts don't survive. A flint blade here, a pottery shard there, a dark stain in the soil where a post once stood. Archaeologists rebuild entire societies from fragments, because fragments are all that time allows. So when we ask whether another civilization might have existed millions of years ago, the burden of proof becomes immense. It's not that we haven't found their ruins. It's that the odds of anything surviving that long are almost zero. And even if something did survive, it would have to escape every force that erases: erosion, burial, subduction, metamorphosis. It would need to endure in a place untouched by time's machinery. A perfect geological niche. Think of how we find impact craters. These are vast, unmistakable wounds, some hundreds of kilometers wide, yet even they can be hard to identify. Over eons, they're softened by weather, filled by sediment, or hidden beneath forests and oceans. Sometimes we only detect them through gravity anomalies or magnetic signatures in the rock. Now imagine searching for something smaller, a city, a monument, a single carved stone. Unless it was buried in a unique and stable environment, it would vanish beyond recognition. Even then, preservation alone isn't enough. Someone has to be looking at the right time, in the right place, with the right tools, and with the right kind of question. Most paleontological digs aren't searching for evidence of intelligence. They're searching for species, ecosystems, extinction events. They read the sediments for life's rise and fall, not for blueprints or roads. And even when something unusual turns up, the first assumption isn't civilization, it's natural process. And that's a fair assumption because nature is capable of incredible complexity. Crystals grow in symmetrical patterns, erosion sculpts arches and spirals, minerals form shapes that mimic architecture. Without clear context, the line between natural and artificial can blur completely. A perfect sphere could be a sculpture, or a concretion, a mineral curiosity formed by pressure and time. Without evidence surrounding it, we simply can't tell. This is why the Silurian hypothesis, and studies like it, focus on indirect evidence. Instead of searching for monuments, it asks, what did they change? If an ancient civilization once reached industrial scale, it would have altered the planet's chemistry, atmosphere, or sediment layers in detectable ways. Carbon isotopes, rare metal spikes, artificial compounds, these are the geological equivalents of fingerprints. But even fingerprints fade. Natural processes can mimic them. Volcanic eruptions, methane bursts, asteroid impacts, all of these can produce chemical signals that resemble industrial activity. The challenge then isn't just finding evidence, it's interpreting it, separating deliberate impact from natural catastrophe. That requires humility. Not because the idea of a vanished civilization is likely, but because ruling it out completely demands a certainty that Earth's restless nature doesn't permit. We like to think of history as a line, a clear beginning, a straight path, an end. But the Earth's history is not a line. It's a loop of pressure, heat, erosion, and renewal. It writes, erases, and writes again. And in that endless rewriting, most of what was ever built, spoken, thought, or dreamed on this planet is gone. Not hidden, simply undone. If the Earth is so good at erasing, then what, if anything, can resist that eraser? What could truly last? Not for centuries or millennia, but for millions of years. The answer, it turns out, isn't architecture or art, it's chemistry. Let's begin with fossils, the most familiar survivors of deep time. When most people hear the word fossil, they imagine a museum skeleton, an ancient creature preserved perfectly in stone, each bone in place, as if time simply turned flesh to rock. But real fossils are rarely like that. They're fragmented, partial, compressed beyond recognition. They are accidents, the rare result of extraordinary circumstances. For fossilization to occur, a creature must die in just the right environment, buried quickly, protected from oxygen and scavengers, and surrounded by sediments rich in minerals that can slowly replace organic material. Even under these conditions, the process is fragile. Too much movement, too much erosion, and the fossil is lost before it ever forms. And even when it does form, survival over millions of years is far from guaranteed. A shift in temperature, a rising sea, a mountain forming overhead. Any of these can destroy a fossil long before it's found. The fossil record, despite its scientific value, tells only part of the story, like reconstructing an entire movie from a few scattered frames of film. For every species we've identified, dozens, perhaps hundreds, are missing entirely. Some never fossilized, some were fossilized but later destroyed. Others still sleep in rock layers no one has touched or may never reach. In short, the record of life on Earth is filled with blind spots, vast spans of time where we know almost nothing. Now, imagine trying to preserve not bone or shell, but something even more fragile, a tool, a structure, a trace of technology. The odds collapse completely. Even stone tools, resilient as they are, can be impossible to recognize if found out of context. A chipped rock might be a crafted blade, or it might just be a chipped rock, without surrounding evidence, a hearth, a dwelling, a layer of habitation. Meaning disappears. Metal corrodes, fabric decays, wood burns, rots, or dissolves. Even plastic, our most stubborn invention, breaks down in sunlight and air unless it's sealed away from oxygen. Time is patient. It doesn't need to hurry, so what could endure? Not individual objects, but global traces, shifts in the chemical balance of the planet. Industrial activity leaves behind subtle, measurable changes. Carbon isotope ratios altered by fossil fuel use, synthetic elements that don't occur naturally, radioactive isotopes that trace nuclear events. These are markers written into stone, soil, and ice. Even so, they fade. Weather, tectonics, and erosion dilute or destroy them over the course of millions of years. If another civilization had reached a technological phase eons ago, its presence might exist only as a chemical whisper, a slight anomaly in the layers of rock, misread as a natural event. And that's the sobering reality. When we imagine forgotten worlds, we picture buried cities and shining ruins, but the truth is quieter and lonelier. If others came before us, they might have left nothing but a few altered molecules trapped in minerals that no one has yet studied closely enough to notice. Even now, the evidence of our own age is being layered into the Earth's crust. Plastic sediments, concrete dust, nitrogen compounds, carbon soot. We are writing our signature across the planet in materials both delicate and durable, but even that won't last forever. In 10 million years, a handful of signals might remain. In 100 million, perhaps only one. A faint chemical echo marking a brief experiment in intelligence. And someday, if someone else arises to study the distant past, they might look at that signal and ask the same question we're asking now. Were we the first? Or just the latest in a long-forgotten chain of worlds that built, dreamed, and disappeared? Time to us feels like a river flowing forward, carrying moments downstream. But to the Earth, time isn't linear. It folds, collides, erases, and begins again. The planet has no nostalgia. It remembers only what it cannot transform. When we think about history, we see lines, beginnings and endings, causes and effects. But in geology, history is written not in order, but in layers. Each layer tells a story of change. Sediment falling in a river, ash settling after a volcano, dust drifting from deserts to sea. Each new layer hides the one before it. Every moment buries another. It's easy to think of the Earth as a keeper of records, a planet of archives. But that's not quite true. The Earth is not a library. It's an editor. It rewrites constantly. Not out of malice, but through the same processes that make it alive. Heat, pressure, water, and motion. Everything that once stood proud on its surface, cities, forests, mountains, is slowly pulled back into its depths, recycled into new worlds. It's not that the past is gone, it's that it has become something else. Every rock beneath our feet was once part of something larger. A seabed, a desert, a mountain, a living creature. Every fossil, every crystal, every grain of sand is a fragment of something that time has repurposed. The Earth is not static. It breathes in epochs. And in that breathing, it forgets almost everything. If another civilization once walked this planet, its traces may now lie beneath our oceans, dissolved in limestone, compressed into coal, or transformed into elements so ordinary we would never think to question them. The question, then, isn't simply whether they existed, but whether existence itself can ever be permanent on a living world. Even our own civilization, vast, noisy, illuminated, will one day be a layer in stone. One more stratum among billions. A whisper pressed between epochs. Perhaps that is what civilization truly is. Not a monument to endurance, but a moment of awareness within time's great forgetting. And yet, there's something oddly comforting about that. Every discovery, every tool, every idea, all of it is part of the same grand cycle of emergence and erasure. Even if nothing survives, the pattern continues. The act of asking the question, were we the first, becomes part of that pattern too. It means that curiosity itself is one of the few things that transcends extinction. Maybe that's the real story hidden beneath the layers. Not proof of ancient empires or lost technologies, but the simple, enduring impulse to wonder. Because every civilization that ever existed, human or otherwise, shared one thing in common. They looked at their world and tried to understand it. And that, more than any monument or artifact, may be the truest legacy the Earth remembers. So the next time you look out across the land or up at the night sky, consider this. You're standing on the bones of countless forgotten worlds. Every step, every breath, every thought is part of a story that began long before us and will continue long after we're gone. The planet forgets, but it also renews. And in that cycle of forgetting and rebirth, it keeps just enough of us to begin again. Even for our own ancestors, the record we hold in our hands is painfully incomplete. Take Homo erectus, a species that thrived for nearly 2 million years. We have their tools, fragments of their bones, faint traces of their use of fire. But most of what they did, thought, and believed has vanished. They walked across continents, adapted to climates from the tropics to the tundra, likely spoke or gestured in ways we can only imagine. Yet we don't know what they dreamed about, how they organized their lives, or what stories they told each other beside the flames. Not because they left no signs, but because the Earth did not keep them. When we dig into the fossil record, we are digging into chance, into the stories of the few who were lucky enough to fall in just the right place, beneath the right layer of sediment, shielded from pressure, heat, and time. That is why mass extinctions leave such clear layers in the rock. They are moments when death came suddenly, when countless organisms were buried faster than decay could erase them. The richest layers of fossils mark moments of crisis, not moments of flourishing. If we hope to find evidence of an intelligent species that lived long before us, our chances would depend on the same rare conditions. They would have to live near one of these fragile, preservation-friendly zones, and then meet a catastrophe kind enough to trap them quickly in stone. It's a narrow window, and that assumes they even left bodies at all. Intelligent beings might handle their dead differently. They might cremate, expose, or release them to sea. They might have methods that ensure decay, not preservation. And if their technology advanced far enough, they might stop leaving biological remains altogether. What if consciousness itself left the body behind? What if thought had moved into machines, networks, or materials that no longer fossilized? In that case, the record would not merely be silent, it would be irrelevant. Even now, most of the matter that defines human life is synthetic, engineered, refined. If a future geologist millions of years from now were to examine our layers, they might find thin seams of polymers, scattered alloys, or residues of rare elements. Without context, they might never guess those were the ashes of a civilization. A faint band of titanium dust in a 100-million-year-old core sample might raise a question, or be dismissed as an anomaly. Interpretation matters as much as discovery. And that brings us to an uncomfortable truth. Every record carries bias, not only in what it preserves, but in what we allow ourselves to see. We tend to find what we expect. A vanished civilization doesn't fit easily into the frameworks of modern science. So unless the evidence is overwhelming, it's cataloged as natural variation or unexplained deviation. Not through neglect, but through caution. Science favors the simplest explanation that fits the data, and vanished civilizations are anything but simple. That's why the fossil record is honest but incomplete. It tells us only what the planet permitted to endure, what happened to fall in our path, and what our minds are prepared to recognize. It tells us a partial truth, the story of survival, not of existence. Still, the Earth speaks in more than bones. It keeps other kinds of records, signatures written not in skeletons or tools, but in chemistry, in the air and soil, in the slow pulse of the oceans. Traces not of bodies, but of processes. And that is where our search turns next, to the evidence that outlives life itself. In 2018, two scientists, Gavin Schmidt, a climate researcher at NASA, and Adam Frank, an astrophysicist from the University of Rochester, posed a question that sounded almost like science fiction, but wasn't. They asked, if an industrial civilization had existed millions of years before humans, would we even be able to detect it in the geological record? They weren't arguing that such a civilization had existed. Their goal was to ask whether science itself would recognize one if it had. They called their thought experiment the Silurian hypothesis, a nod to an old British science fiction series in which intelligent reptilian beings, the Silurians, once ruled the Earth before humanity appeared. But their paper wasn't about aliens or myth. It was about the limits of geology and the nature of evidence. Could an entire technological epoch be compressed, buried, and erased so completely that only its chemical shadow remained? The premise was simple but profound. If an industrial civilization, something like ours, had risen 50 or 100 million years ago and then vanished, what traces would survive? Would the planet still carry a fingerprint of their existence, however faint? Schmidt and Frank began with what we already know, that our own civilization is leaving such fingerprints right now. We are changing the composition of the atmosphere. We are altering the chemistry of the oceans. We are seeding the soil and sediment with synthetic compounds that have never before existed in nature. Plastics, fertilizers, pesticides, industrial byproducts. All of them are entering the Earth's layers as we speak. These changes are global, durable, and measurable. They will persist, in some form, long after we are gone. So the question becomes, which of these signals will last the longest? And if they lasted for millions of years, would they look any different from a natural event? Would a future scientist studying our layer of the rock record even realize that intelligence was responsible? The researchers broke this question into a few key categories. One is geochemical anomalies, measurable deviations in the natural balance of stable isotopes, such as carbon, oxygen, and nitrogen. For instance, when humans burn fossil fuels, we release vast amounts of ancient carbon into the atmosphere. That process changes the ratio of carbon-13 to carbon-12, a signature that settles into sediment and ice. If something similar happened millions of years ago, we might interpret it as a volcanic event, or perhaps never notice it at all. Another possible clue is synthetic materials, compounds that do not occur in nature. Our world produces plastics and polymers that decay slowly, some capable of persisting for tens of thousands, perhaps hundreds of thousands of years. Tiny particles called microplastics are already embedded in ocean floors, mountain snow, and even in the air we breathe. If an ancient layer of rock contains similar, non-natural polymers, it would raise difficult questions. A third category is fossil fuel combustion. Industrial civilizations need energy. Burning carbon-based fuels leaves a distinctive trail. Carbon dioxide spikes, soot layers, and residues like fly ash. These can accumulate in sediment much like the ash from volcanic eruptions. And then there is extinction. Human activity has already triggered a sharp decline in biodiversity, sometimes called the sixth mass extinction. Such collapses leave unmistakable marks. Sudden drops in species diversity, a thinning of fossil layers, a narrowing of genetic variation. If a similar event occurred long before us, without an asteroid or supervolcano to explain it, the possibility of a technological cause could not be dismissed easily. But here's the problem. Nature is deceptive. The Earth itself can produce similar patterns. 56 million years ago, during the Paleocene-Eocene thermal maximum, global temperatures spiked, oceans acidified, and carbon levels surged, all in ways that look eerily like our current age. No one knows the exact cause. Perhaps it was volcanic, perhaps methane release, or perhaps something stranger, now erased. So how can we tell the difference between a natural cataclysm and an artificial one? That is the heart of the Silurian hypothesis. Not proof, but method. It doesn't claim that a civilization came before. It asks whether, if one had, we would even be able to see its ghost in the data. And more importantly, it asks what our own signal will look like when we are gone. Because even our most enduring markers, plastics, isotopes, metal residues, are not eternal. They decay, they erode, they are subducted, melted, and remade. If any survive, they may be scattered beyond recognition, faint chemical hints without context, buried deep in a world that has forgotten us. This thought experiment forces a shift in perspective. It asks us to stop searching for monuments and start thinking like planetary archaeologists, to look for subtle, indirect clues, small deviations in chemistry, irregularities in sediment, disruptions in ecology. And above all, it invites humility. Because if our civilization, vast and global as it is, can vanish almost without a trace, then how many others could have already come and gone, leaving behind only silence and stone? Imagine this. Tomorrow, every human being disappears. No warning, no war, no catastrophe, just silence. What would the world look like a year from now? 100 years? 1,000,000? It's a grim, strangely peaceful thought experiment. One that helps us understand what traces a civilization like ours actually leaves behind, and how long they truly last. At first, nothing would seem unusual. Cities would still glow at night, cars would wait obediently in driveways, planes would sit idle on their runways. But without people, the delicate systems that hold modern life together would start to unravel almost immediately. Power plants would run out of fuel or overload, lights would flicker and fade, water treatment facilities would stop pumping, the silence would spread, mechanical at first, then organic. Within weeks, the streets would begin to change. Without constant repair, asphalt would crack. Weeds would push through. Seeds carried by the wind would find new homes in empty yards, gutters, and rooftops. Animals would return. First the quiet ones, then the bold. Rodents, birds, foxes, coyotes. In time, deer would wander downtown. Predators would follow. The line between wild and built would blur until there was no line at all. In the subways beneath New York, Tokyo, or London, pumps would fail within days, flooding tunnels that had stayed dry for a century. Steel would rust. Concrete would spall. Glass towers would begin to break down from wind and weather. Decades later, trees would sprout through sidewalks, their roots tearing up the pavement. Bridges, without maintenance, would corrode and eventually collapse. Concrete, though seemingly eternal, is brittle under the slow assault of water and frost. Inside its skeleton, rebar rusts, expands, and bursts the structure apart from within. Roads would crumble. Highways dissolve into dirt tracks overgrown with grass and moss. Airports would turn into wetlands. Fields would revert to forest. Above us, satellites would fail one by one as their batteries died and solar panels degraded. Most would deorbit and burn up. A streak of light in a sky no one was left to see. Only the most distant craft, drifting in the void, might persist. Silent testaments to a species that once reached for the stars. After 1,000 years, the transformation would be nearly complete. Steel bridges would be gone. Buildings would have collapsed into piles of dust and rebar. Plastics left on the surface would have shattered into microscopic fragments. Underground pipes and cables would corrode. From above, the scars of roads and cities might still be faintly visible, geometric ghosts imprinted on the land. But they would look more like natural patterns than like the remains of design. After 10,000 years, even those traces would fade. Forests would retake the temperate zones. Deserts would shift and bury what was once civilization. Coastlines would reshape themselves under the pressure of wind and tide. Everything familiar would melt back into landscape. Some monuments might endure longer, those carved from stone and set in arid climates, the pyramids, the temples of Angkor, Mount Rushmore's faces staring blankly from the rock. But even they would crumble, grain by grain. After 100,000 years, almost every structure we ever built would be gone. Only the deepest foundations, the sturdiest landfills, and the scars of mining and quarrying might still hint that something once shaped the surface differently. Those, too, would weather and fill with sediment until they became part of the Earth's geology. Curious, but unremarkable. After 1,000,000 years, nearly nothing would remain. A few artifacts might survive in the most stable and sealed environments. Dry caves, deep salt formations, or polar ice. A handful of synthetic molecules might resist decay, complex plastics, or trace isotopes buried in rock. And in the planet's chemical memory, its sediments and ocean floors, there would remain the faintest of signals, a spike in carbon, a drop in biodiversity, strange concentrations of metals or particles that nature never made on its own. Those would be our fossils, not statues or buildings, but chemistry. Thin, scattered, and subtle, yet distinct enough to mark the passing of something deliberate. If humanity vanished tomorrow, the Earth would begin erasing us the same day. Not cruelly, not with intent, simply because that's what living planets do. They recycle, they reset, they heal. Erosion, decay, subduction. These are the slow mechanics of forgetting. And given enough time, the evidence that we ever existed would become harder and harder to prove. That's not just a poetic thought. It's the central question of the Silurian hypothesis. If even we, with our satellites, skyscrapers, and nuclear power, could vanish so completely, how could we expect to find the traces of anyone who came before? The answer, perhaps, is that we shouldn't expect them at all. Only remain open to the possibility. Because if anything of us does endure, it will not be our monuments or machines. It will be our impact, the way we changed the chemistry of the planet itself. And that, scientists argue, is what we should look for when we ask the oldest question in the world. Were we truly the first? Geologists do not speak in years the way we do. They don't count in centuries or generations. They speak in layers, in sediments, isotopes, and thicknesses of rock. To them, time is not a line. It's a stack. Deep time doesn't tell stories in words. It tells them in chemistry. And if we want to ask whether another civilization might have existed long before ours, we must learn to think in that language. The quiet, patient grammar of stone. Most of what we know about the Earth's past doesn't come from fossils at all. It comes from the composition and structure of sediments, from ocean cores, lake beds, polar ice, and the colored bands of exposed cliffs. These layers form slowly, one grain at a time. Dust settles in lakes. Shells rain down to the ocean floor. Volcanic ash drifts across continents and sinks through the sea. Each layer holds a record of its age. Tiny traces of the world that was, its temperature, its chemistry, its life. Over time, those sediments compress into rock. Stacked together, they become the Earth's diary. Not continuous, not perfect, but eloquent in what it chooses to remember. Scientists call this the language of deep time. It has no alphabet, but it has a vocabulary. Carbon levels, oxygen isotopes, sulfur ratios, pollen grains, trace metals, magnetic alignment, Together they tell a story of atmosphere and ocean, of ice and fire, of species rising and falling. From these clues, we can read the outlines of entire worlds. We can see when the air thickened with carbon, when the seas warmed, when forests spread or vanished. We can even trace the fingerprints of catastrophe: asteroid strikes, volcanic winters, global extinctions. And occasionally, hidden among these natural rhythms, we find something stranger. The most detailed records come from places that change slowly and preserve well: the still basins of deep lakes, the ocean floor where sediment rains down undisturbed, and the cold, ancient ice of the poles. Here, scientists drill long, perfect cylinders called cores, frozen or compacted cross-sections of time. Each centimeter of a core can represent decades or centuries. Each shift in color, grain, or composition marks a change in the planet's story. They look for patterns, subtle chemical deviations, abrupt changes in particle size, the presence or absence of certain isotopes. Sometimes, a single shade of gray, a faint band of dust, or an unexpected element is enough to tell them something happened. Something big, something fast. A slight increase in a rare metal, an unexpected carbon ratio, a sudden surge of nitrogen or oxygen isotopes. Individually, each might seem random. Together, they become a pulse, the echo of a moment when the planet's normal rhythm faltered. Our own civilization is now writing such a layer. Future geologists, if they ever exist, will see it clearly. A spike in carbon dioxide, a drop in biodiversity, residues of plastics, pesticides, and radioactive isotopes from nuclear tests. A thin, unmistakable band. The Anthropocene, the proposed epoch of human influence. Against the long calm of geological history, it will stand out like a scar. Not a full story, but a disruption. A brief, bright anomaly in the planet's patient rhythm. And if something like this had happened before, if another intelligence had once changed the Earth as dramatically as we are changing it now, then the traces might look similar. A spike here, a chemical imbalance there, buried deep within ancient stone. But detecting is one thing, interpreting is another. For every unexplained carbon shift or metal anomaly, there are natural explanations too. Volcanoes can release carbon, asteroid impacts can scatter iridium, algae blooms can leave mysterious chemical residues. The planet has its own catalog of chaos, and it often imitates the signals of civilization. That's why context is everything. A single anomaly means little, but a cluster of anomalies, a global shift in chemistry, a temperature rise that matches a sudden extinction, a layer rich in synthetic compounds or isotopes, begins to whisper a different kind of story. And yet, even then, it would only whisper. Because the deeper we look into time, the fainter the evidence becomes. The rock record is not a perfect archive. It folds, warps, melts, and erases itself. Nothing stays clean. Nothing stays still. Still, some signals are stubborn. Certain isotopes decay so slowly they can mark time for millions of years. Magnetic minerals record the ancient flips of the Earth's field, creating a kind of cosmic timestamp. Some minerals form only under specific conditions, at particular temperatures or chemical balances, serving as precise fingerprints of moments long gone. If a civilization ever altered the planet strongly enough, and in just the right ways, its traces might still exist in these stubborn pages of rock, though almost impossible to recognize for what they are. Even today, scientists occasionally encounter unexplained spikes and shifts in the geological record, chemical events that don't match known eruptions, impacts, or natural cycles. Most are eventually attributed to ordinary causes. Some are simply left unresolved, quiet mysteries in academic papers, not ignored, but paused, waiting for better context. Science, after all, needs patterns, not single points. It cannot act on rumor or coincidence. That caution is its strength, but it's also why some possibilities may remain forever unasked. Because if an ancient civilization's mark was faint or brief, a flicker in a million years, it might appear only as a small irregularity in the great rhythm of nature, filed away under unexplained anomaly, not hidden, not denied, just misunderstood. Some things fade almost instantly: paper, cloth, wood. Others resist for a while: glass, metal, concrete. But a few things outlast civilizations, not because they were meant to, but because they happen to endure the forces that erase everything else. If we want to imagine the traces of a civilization older than memory, we have to think in those terms, not in architecture or art, but in what survives. And that list, as it turns out, is short. One of the most persistent legacies any species can leave is chemical. Every act of mining, combustion, or synthesis changes the planet's composition. Metals are concentrated, isotopes are rearranged, and entirely new molecules are born. These transformations become written into the slow record of sediment and soil, a quiet, global graffiti. Future scientists might not know who caused it, but they would know something happened. Start with synthetic materials. Modern humans produce an astonishing variety of substances that nature never made. Plastics, polymers, pesticides, rare alloys, and industrial chemicals. Some of them decay quickly in sunlight or oxygen, but others, buried in the right conditions, cold, dark, and airless, could persist for tens or even hundreds of thousands of years. Already, microplastics have been found at the bottom of the deepest ocean trenches, in polar snow, and drifting through the upper atmosphere. These particles will be pressed layer by layer into future rock. If another species someday found them, they might mistake them for a curious mineral, unless they looked closer and saw the unmistakable geometry of manufacture. Yet even plastic has limits. At the surface it becomes brittle, turns to dust, and disappears into chemistry. Without context, a layer of strange polymers might look like nothing more than a quirk of geology. Then there is metal. We like to think of it as immortal, but it isn't. Iron rusts, copper greens, aluminum and steel corrode. Even stainless steel, our most stubborn alloy, succumbs eventually to time, moisture, and pressure. A buried sword may survive a few thousand years, a skyscraper perhaps less. But 1,000,000 years? Only the faintest trace of its composition might remain, blended back into ore. A piece of refined metal sealed deep inside a mountain might endure longer. But even then, stripped of shape, it would be indistinguishable from natural deposits, unless someone recognized its unnatural purity. Radioactive isotopes offer another kind of signal. Some elements are born only through deliberate nuclear reactions. Plutonium-244, Curium-247, or the transuranic elements that do not occur naturally in measurable quantities. If they were ever found outside known cosmic or volcanic contexts, they would be clear evidence of technology. But most of them decay too quickly. After millions of years, only faint ghosts would remain, blended into background radiation. Still, a few isotopes, technetium-99, iodine-129, decay slowly enough that, under perfect conditions, traces could persist as long as the planet's crust itself. They would be rare, almost undetectable, but real. The most subtle and lasting mark of intelligence might come not from construction but from combustion. When carbon-based fuels are burned, they alter the isotopic balance of the air. The ratio of carbon-13 to carbon-12 shifts downward, a signal of massive, rapid carbon release. In the geological record, this fingerprint would appear as a thin global line, a moment when the planet inhaled deeply of something ancient. We already see such spikes in our own time, the direct result of our industry. If a similar anomaly appeared in sediments from 100 million years ago, we might debate whether it was caused by volcanic activity or something else entirely. Because nature can mimic us, and we can mimic nature. The distinction is never clear. But if multiple signals lined up at once, carbon imbalance, synthetic compounds, isotopic radiation, and a mass extinction, then the simplest explanation might no longer be purely natural. That, in the end, is what the Silurian hypothesis invites us to consider. Not a lost empire of myth or monsters, but the humility to admit that even intelligent life might leave little more than a chemical whisper. Every civilization, if it lasts long enough, learns the same truth. The planet is patient, and time is thorough. Stone forgets slowly, but it forgets. And perhaps that is the most profound lesson of all. If something came before us, it is gone not because it was small, but because Earth does not keep souvenirs. If the Earth could speak, it wouldn't use words. It would speak in pressure and silence, in the slow folding of mountains, in the steady drift of continents, in the quiet recycling of everything that ever lived. It remembers not through memory, but through transformation. What burns becomes air. What decays becomes soil. What erodes becomes ocean. And what endures, the faintest isotope, the trace of a polymer, the balance of carbon in stone, is not a story, but a signature. A single line in an endless book that keeps rewriting itself. To the human mind, history feels long. We measure it in reigns, empires, generations, in the fragile scale of a heartbeat stretched across centuries. But to the Earth, we are a flicker, an echo, a pulse in the deep strata that will someday flatten into silence. Even now, we live atop the ghosts of worlds we cannot name. Continents that have sunk and reformed, mountain ranges that rose and vanished, oceans that opened and closed again like slow breaths. Beneath our feet are the ashes of civilizations, microbial, biological, maybe even intelligent, and the planet holds no judgment, only process. It takes, it changes, it renews. When scientists drill into ancient sediments, they are not just studying history. They are listening to a planet that speaks across billions of years. And somewhere, buried in that language, may lie the faint echo of something that once asked the same questions we do now. What is our place in this story? Are we its first authors, or merely its latest translators? Maybe intelligence has bloomed and burned here more than once. Maybe the universe tries, again and again, to become self-aware, and then lets time take it back. If so, the silence we hear is not emptiness, it's continuity. A cycle of curiosity and forgetting, life rising to ask the same eternal questions, and the Earth, patient as ever, listening without reply. And as for us, our monuments will fade, our cities will fall, our satellites will burn, and our names will vanish. But for a brief moment in deep time, we were here. We looked up, we wondered, and we left behind, in stone and chemistry, a quiet proof that wonder itself had once existed. When coal or oil burns, it leaves behind a distinct chemical fingerprint, a subtle alteration in the balance between carbon-13 and carbon-12. A sudden, planet-wide drop in that ratio, if discovered within ancient sediments, could suggest a period of intense combustion, a moment when something burned fuel on a massive scale. Yet the planet has its own ways of imitating that signal. Volcanic eruptions, vast methane releases, and other natural events can produce similar isotopic patterns. To identify technology, rather than nature, we would need more clues, independent signs that point toward deliberate activity rather than coincidence. One such clue might lie in unusual concentrations of metals, lead, cadmium, or the rare earth elements used in modern electronics and manufacturing. Mining and refining leave behind waste, often toxic, often clustered in unnatural patterns. If ancient soils or sediments revealed these elements in suspiciously high, uneven quantities, arranged not by geology, but by process, they might whisper of industry. But metals travel. They leach through rock and groundwater. They accumulate in living things. They migrate with the slow breathing of ecosystems. Isolating an artificial source would be anything but simple. Then there are structures, the physical scars left on the planet's surface. Massive earthworks, quarries, tunnels, or underground chambers could outlast cities made of glass and steel. If they changed the shape of local geology, they might persist long after their builders vanished. But after tens of millions of years, tectonic drift, erosion, collapse, and burial can erase even the grandest design. Without clear geometry, straight walls, right angles, repeating patterns, a mine becomes indistinguishable from a cave, a quarry from a canyon. Concrete is surprisingly durable. Some kinds even strengthen over time as minerals react with moisture to form new bonds. Roman concrete has survived more than 2 millennia, often underwater, and some modern formulations might last far longer. But environment decides everything. Temperature shifts, rain, salt, and roots all conspire to grind it down. Given geological time, even concrete becomes anonymous, just another odd layer of stone. Ceramic and glass fare better. Chemically stable, resistant to decay, they are among the most enduring traces of humanity. Fragments of pottery from ancient civilizations still emerge from the earth nearly intact. Buried in stable conditions, ceramics could last millions of years, but a shard alone says little. To suggest intelligence, it must bear the marks of intention, symmetry, decoration, or appear in concentrations too dense to be natural. Beyond the physical, there are ecological traces, changes to soil, vegetation, and water chemistry. Modern agriculture reshapes landscapes on a planetary scale. It compacts soil, drains wetlands, depletes nutrients. Irrigation alters salinity. Fertilizers leave chemical residues. Monoculture and deforestation reduce biodiversity, while erosion patterns shift beneath plows and roads. Even long after abandonment, these scars linger in the layers of soil, sometimes for thousands, even tens of thousands of years. Still, that is a blink compared with deep time, a trace destined to fade, but perhaps strong enough to catch the eye of some future geologist. If an earlier civilization once existed, its legacy would not shout through monuments. It would whisper through patterns, not objects, but anomalies. A rhythm interrupted. Something in the sediment that simply doesn't belong. To find such signals, to recognize them for what they are, and to resist dismissing them as random noise, that would be the real challenge. The signals that vanish fastest are all around us. Books, photographs, paintings, music, the fragile archive of our daily lives. They are the first to go. Paper burns or rots. Digital storage decays as soon as the power stops flowing. Cultural memory, the stories, symbols, meanings, fades even faster than stone. Within a few generations, languages die, beliefs dissolve, and what once felt permanent becomes myth. So we return to the question, what truly lasts? Perhaps not much, but maybe enough. Enough to leave a trace, if not a story. Enough to make someone someday stop and wonder not who we were, but whether someone once was. To test that idea, we have to look at the most dynamic and unforgiving archive of all, the ocean. If civilization ever touched the seafloor, the sea did not keep its secrets. It broke them apart, grain by grain, molecule by molecule. The ocean doesn't preserve, it edits, it takes, dissolves, buries, and remakes. For any species that live beside it, as we do, the water must have seemed a gift, not a threat. It connects continents, sustains life, provides food and trade. Yet over geological time, it is merciless. It erases, it resets. A civilization that built its world near the shore would have left its remains in the ocean's reach, the very zone that moves the most. And if those remains sank beneath the waves, their odds of survival across millions of years would approach zero. Still, the question stands. If a technological species once lived and worked beside the sea, could anything of it remain? Could the ocean itself hold a memory? Start with what we know. Today, most of humanity's great cities stand by the coast. The advantages are obvious: trade, food, a stable climate. But those same advantages hide a risk. Coastlines shift, tides reshape them, storms tear them apart, and on a planetary timescale, the oceans rise and fall like breath. In the last 20,000 years alone, the sea has climbed over 100 meters, flooding vast plains that were once dry land. Rivers that once wound across those shelves are now drowned valleys. People once lived there. Now they are ghosts beneath the waves. The seafloor hides those ancient landscapes buried beneath layers of sediment and salt water, difficult to reach and harder still to study. And that is precisely where any early civilization would be hardest to find. Not because it is impossible that such a civilization existed, but because the ocean has made its evidence almost perfectly inaccessible. Underwater archaeology is demanding even in shallow depths. On submerged continental shelves blanketed by post-glacial silt, it becomes nearly impossible. Suppose a long-gone culture once built harbors, piers, or coastal towns. Wood decays, rope disintegrates, stone collapses under waves, metal corrodes in salt. Only quick burial in oxygen-poor sediment could preserve anything, and even then, only for a few thousand years. A heartbeat in deep time. After millions of years, nothing would remain recognizable. And even if it did, how would we notice? A straight line on the seabed, a faint geometric pattern in sonar data. Nature makes those too. Without artifacts or context, a ruin is indistinguishable from a reef. Now imagine a civilization that didn't just live near the sea, but used it heavily for energy, for mining, for waste. Would such use leave a mark? We already know ours does. Plastic gyres swirl across the oceans, mercury and lead-poisoned fish. Radioactive isotopes from mid-century weapons tests drift through the deep currents. Nitrate runoff from farms fuels coastal dead zones. Microplastics have reached the bottom of the Mariana Trench. Some of these pollutants may persist for tens of thousands of years, especially when buried under fine sediment. If another civilization had once altered marine chemistry on a global scale, the trace might still exist. Subtle, faint, but measurable. The problem is interpretation. Hydrothermal vents, volcanic eruptions, and organic decay all leave their own strange signatures. To separate technology from geology requires a level of context that deep time rarely allows. This is the essence of what scientists call the lost tech test. Could any product of technology survive long enough to be read as evidence? And if it could, would anyone recognize it for what it was? Synthetic molecules, plastics, polymers, fluorocarbons do not occur naturally and resist decay. Buried without oxygen, they might endure for hundreds of thousands of years. But a single fragment proves nothing. Only a pattern, a widespread, consistent signal across many regions and layers, would hint at deliberate origin. Finding that pattern would demand data from across oceans, depths, and epochs, a kind of planetary archaeology that we are only just beginning to attempt. Heavy metals and rare earth elements tell another part of the story. They are the bones of modern industry, vital for electronics, batteries, and machines. Mining them concentrates what nature has spread thinly through rock. Refining them leaves chemical scars. If some ancient civilization had done the same, those scars might still exist in the layers of the sea or soil. But interpretation is a fragile art. Volcanoes and hydrothermal vents also enrich sediments with metals. The Earth's crust constantly sorts, melts, and remixes its ingredients. To tell human industry from geologic chemistry, one would need ratios, context, and a baseline. A map of what normal once looked like millions of years ago. And that is exactly what we don't have. Even deep-sea mining, a practice we are only beginning to explore, would blur into natural geology over time. Sediment disturbed, layers rearranged, minerals removed or replaced. In theory, such changes might be detectable. But how do you prove an absence? How do you recognize a missing mineral as the fingerprint of technology and not chance? Energy use is another clue. Every complex civilization burns or transforms something for power. Fire, fission, fusion. The source may differ, but the signature remains. Heat, gases, residue. For humans, that signature includes carbon dioxide, industrial pollutants, and waste heat. In the ocean, it shows up as warmer water near coasts, altered currents, dying coral reefs. If a civilization millions of years ago had harnessed energy on a planetary scale, the after effects might linger in chemical form, traces of radiation, synthetic molecules, or isotopic shifts. But again, the scale matters. Tiny, localized pollution fades quickly. Only a global transformation would leave a mark large enough to survive the grind of time. And even if such traces were found, they would not declare their origin. They would look like chemistry, numbers in a dataset, spikes on a graph. Without context, they are noise. Only patterns give them meaning. And patterns are hard to read in the language of stone. That is the cruel paradox of the lost tech test. It is not about whether something existed, but whether it can still be seen. Could the right combination of materials, processes, and environments allow even a sliver of ancient technology to endure? And if it did, would we recognize it or dismiss it as a statistical glitch in nature's rhythm? Geologists today already find oddities that fit this mold. Spikes of rare isotopes, strange metals, thin layers of sediment that don't match their surroundings. Most are eventually explained: volcanic dust, asteroid impact, methane release. But perhaps a few are not. Perhaps some tiny fraction of the unexplained is not natural at all. Even then, the challenge is recognition. Science is careful by design. It resists extraordinary claims without extraordinary proof. An anomaly in a rock core is not enough to rewrite history. It would take multiple signals, chemical, geological, and perhaps biological, all pointing in the same direction before the idea of a previous civilization would be taken seriously. And that brings us to the heart of the matter. Even if the traces exist, they would not resemble our expectations. They would not be temples or tools, but ratios, compounds, isotopes, stories told through chemistry, echoes written in data rather than stone. Such a discovery might already be in our possession, misfiled in a database under unexplained. A set of numbers from a sediment core, a thin layer rich in metals, a chemical pattern too precise to be random. Not dismissed, but not pursued either, waiting for the right question. When the tools of geology reach their limits, and archaeology runs out of artifacts, what remains are stories. Not measurements or fossils, but words. Fragile, shifting, alive. Myths are the memory of a world without writing. They are oral time capsules, passed from one voice to the next, changing as languages evolve, but somehow refusing to vanish. Each retelling blurs details, replaces names, folds centuries into a single heartbeat. Yet beneath those distortions, some truths may linger, not in the accuracy of their facts, but in the persistence of their patterns. Across continents and cultures, humanity has told certain stories again and again. Floods that swallowed lands, fire that fell from the sky, stars that descended, islands that vanished beneath the waves. Each tale is wrapped in symbolism, a metaphor for destruction or renewal. Taken alone, they sound like myth. Taken together, they begin to form a chorus, a shared echo of catastrophe. Perhaps they describe ancient floods at the end of the Ice Age. Perhaps volcanic winters, meteor strikes, or rising seas. Or perhaps, somewhere within the metaphor, there lies something more. A fragment of memory, a warning passed across generations by those who did not fully understand what they were remembering. The legend of Atlantis is the most famous of these. A great island empire, advanced and proud, swallowed by the sea in a single day and night. Plato's story was philosophical, not historical, a cautionary tale about hubris, yet its image endures, a civilization lost to time, buried not in myth alone, but under real water. Other cultures tell similar tales. Lemuria in the Indian Ocean, Mu in the Pacific, Kumarikandam in Tamil lore, Aztlan in Aztec legend. Different names, same theme. A world that fell, a people who vanished, a memory the planet itself seems to echo. Modern science treats these stories carefully. They are not evidence, but neither are they meaningless. Geologists can trace real sea level changes, archaeologists uncover drowned river valleys, and paleoecologists study abrupt climate events that may have inspired these myths. The stories, in that sense, are cultural fossils, records of human survival in times of upheaval. But what if some stories reach further back than humans? What if the instinct to tell of lost worlds is older than language itself? Perhaps it is a reflex of intelligence, a species' quiet awareness that it may not be the first to stand in the light. Even if myths are born from imagination, they serve as a bridge, a way for memory to outlive matter. A civilization may lose its cities to the sea, its artifacts to erosion, its words to extinction. But stories, carried by survivors, can leap the gap between epochs. They distort, they adapt, they hide their origins behind symbols. Yet the pulse remains, a sense of something before. And maybe that whisper, faint, impossible to verify, is the truest legacy any civilization can leave. Not a monument of stone, but an idea, carried forward by the species that follows. The Earth forgets almost everything, but not quite everything. A trace always remains. A chemical echo, a fossil shadow, a tilted layer of stone that once lay flat. To read those remnants is to speak the planet's language, a language written without words, in pressure and heat, in erosion and ash. Every civilization, however brief, leaves its sentence in that language. A burst of carbon, a cluster of metals, a shift in climate, and then silence as tectonic time turns the page. Mountains rise where oceans once breathed. Forests crumble into coal. Continents drift, collide, and erase their own signatures. If something came before us, its record is now folded inside the crust, compressed into minerals, rewritten by volcanoes, scattered through the mantle. What survives is not history, but chemistry. And yet even chemistry can whisper of memory. The geological archive is full of absences. Missing chapters, torn pages, epochs reduced to a few millimeters of rock. But sometimes in those gaps, scientists find disturbances, thin lines of dark sediment, anomalous ratios of carbon or oxygen, traces of metals no volcano could explain. Most have natural causes, a few do not fit so neatly. They wait, patient as stone, for someone to notice that their handwriting is unfamiliar. Perhaps they are merely puzzles of nature. Perhaps they are something more. The ashes of forgotten fire, the dust of machines long gone. Either way, the planet keeps them, unconcerned with their meaning. The Earth doesn't care who writes its story. It only cares that the story continues. From time to time, we uncover a layer that feels too familiar. Sudden warming, rising seas, mass extinction. We look at it and see our reflection. Our own age of industry is carving a similar mark into stone even now. Plastic dust in the soil, nuclear isotopes in the air, a planetary fingerprint no weathering can immediately erase. Someday, if another species reads the rock, they will see that mark and wonder. Was it natural? Was it accident? Or was it a moment when the world became aware of itself and left a note in the margin to prove it had been awake? That, in the end, is what the question of ancient civilizations really asks us. Not whether they existed, but what we will look like when we are gone. How long will our footprint last? 1,000,000 years? 100,000? Or will it fade so quickly that even the planet must strain to remember we were ever here? If Earth has erased others before us, it will erase us too. And that is not a threat. It is a truth as old as the crust itself. Civilizations rise, speak, burn, and fall silent. The stone endures. The ocean breathes. the planet remembers only in chemistry and form. But for a brief moment, this moment, we get to listen, to read, to wonder. We get to look down at the rock beneath our feet and up at the sky above our heads and realize that the two are pages of the same book. We are its latest annotation, not its final chapter. One of humanity's oldest and most enduring stories is that of the Great Flood. It appears in the myths of Sumeria and Babylon, in Greek legends, Hindu scriptures, Norse sagas, and of course, in the Bible. Though the details shift from culture to culture, the heart of the story remains the same. A vast deluge sweeping across the world, erasing a civilization and forcing life to begin again. Sometimes the flood is punishment, sometimes renewal. A few are warned, they build boats, climb mountains, or seek divine favor. The message never fades. Everything built by pride or ignorance can vanish overnight. It's tempting to read these tales as metaphors, symbols of rebirth, allegories for seasonal rains or human frailty. But beneath the poetry, there are physical traces that lend the stories weight. At the end of the last ice age, global seas rose more than 100 meters as glaciers collapsed. Whole coastlines disappeared. Valleys that once held villages and forests sank beneath the waves. For the people who lived there, the world must have seemed to drown, and their descendants may have carried that memory in the only form they could, as story. Legends of lost lands echo this same fear and fascination. Atlantis, Mu, Kumari Kandam, High Brazil, each described as radiant, advanced, and doomed. The cause changes. War, arrogance, cosmic justice, but the ending is identical. The land sinks, the people vanish, and only the tale survives. Most scholars classify these stories as fiction, born of philosophy or nationalism. Yet even fiction can preserve a shadow of truth. A submerged land may have been real, even if the details have drifted beyond recognition. Myths also speak of knowledge lost, of an age when humanity knew more, saw further, and shaped the earth with intention. Such stories are not evidence, but they raise a haunting question. Why do so many cultures believe they once understood more than they do now? In these narratives, the fall of a civilization is not only moral, it's intellectual. It is the loss of contact with something greater, a dimming of light rather than a fall from grace. Ancient texts sometimes hint at strange technologies. Flying machines, radiant weapons, cities in the clouds. Most of these are symbolic expressions of power or divinity, but every so often the descriptions become uncomfortably precise, too detailed, some argue, to be pure imagination. Defenders of the myth as memory idea suggest these may be distorted recollections of real events, technologies or disasters passed orally through centuries after their origins were forgotten. Science cannot test this easily. Myths are not data. They lack dates, calibration, or physical context, but they are part of the human record, and when separate cultures tell parallel stories with no shared source, it is worth asking why. Modern anthropologists and archaeologists have begun to look again at that question, not to prove secret continents or alien visitations, but to understand how memory works before writing, how stories endure, adapt, and migrate. In many indigenous traditions, oral accounts have proven astonishingly accurate. Descriptions of rivers, glaciers, eruptions, and migrations, told centuries before written history, now confirmed by geology and archaeology. Myths, then, are not mere fantasy. They are compressed history, shaped by language yet rooted in lived experience. They carry metaphors, yes, but those metaphors grow from something real. Given enough patience, even symbols can be decoded. None of this proves that a forgotten civilization once existed, but it challenges the belief that history begins with ink. The absence of writing is not the absence of memory. And in a world where matter decays but story endures, perhaps myths deserve a second reading. They may not tell us exactly what happened, but they remind us that something did. and that it mattered enough for people to keep the memory alive in the only language that survives the ages: story. We now turn our attention from myth to matter, to the fragments we have pulled from the earth, objects with shape, weight, and texture. Some are ordinary, others strange, and a few raise enough questions to keep the oldest idea alive, that something may have come before us. Tectites, for example, small, glassy beads scattered across continents, dark, aerodynamic, strikingly uniform in composition. Geologists agree they are born in catastrophe. When a meteorite strikes the planet, molten rock is hurled skyward, cooling as it falls back through the atmosphere. They are fascinating, beautiful even, but not mysterious on their own. What makes them intriguing is how often such objects, tectites, metal fragments, shaped stones, are drawn into stories far larger than geology, stories of vanished builders and forgotten machines. Most of those tales collapse under scrutiny, yet some of the artifacts at their center are real. Not alien, not magical, simply unclassified. They sit in drawers of museums and university basements, mislabeled, unstudied, quietly resisting explanation. Not because anyone is hiding them, but because science tends to move past what does not fit cleanly. Then there are the so-called out-of-place artifacts, or OO parts, objects allegedly found in geological layers predating humanity itself. Reports describe metal spheres sealed in billion-year-old stone, carved figures discovered in coal, machined shapes entombed in rock. Almost all have been explained away. Misidentification, contamination, hoax, or natural formation. Yet the persistence of these stories reveals something human, not about ancient machines, but about our hunger for a deeper lineage, a narrative where civilization has risen and fallen many times before. Some of these items remain genuinely puzzling. A polished sphere cut with impossible precision, a copper tool buried in strata thought too ancient for metallurgy, a carved motif in a cave where no known culture should have reached. Nearly every one has a rational explanation. Geology makes shapes of astonishing regularity. Chemical weathering etches patterns that mimic craft. Burrowing animals, moving groundwater, or careless excavation can shift an object through layers and create illusion. But even if none of these pieces prove a lost world, they highlight a truth about deep time. The further back you look, the harder it becomes to prove anything, or to disprove it. Sediment churns, caves collapse. Dating depends on context, and context vanishes easily. If a crafted object truly lay in rock 10 million years old, we would likely assume contamination first, that it had fallen from above, that the sample was mislabeled, that the data were wrong. And most of the time, that skepticism would be correct. But skepticism, while vital, can also blind. If every anomaly is dismissed before investigation, we guarantee that the extraordinary will always remain unseen. Tools, real tools, can endure astonishing spans of time. Stone especially is patient. We have uncovered flint implements more than 2 million years old, clearly shaped, showing wear, passed through generations of hands. Yet even those were once doubted. For years, archaeologists dismissed them as geofacts, naturally broken stones mistaken for tools. Only when repetition appeared, clusters of the same forms, identical wear patterns, did recognition settle in. These were intentional, the product of minds. That lesson matters. The first signs of an unknown civilization would not be cities or temples, but patterns, repetitions of shape, arrangement, or choice, tools inconsistent with local geology, regular designs appearing too often to be random. Such traces would be fragile, subtle, and easily overlooked without context. And context, in deep time, is the first thing to die. Imagine a perfectly smooth sphere, unearthed from a layer of rock dated to 100 million years ago. The instinct would be to doubt the layer, not the sphere, to assume intrusion, contamination, error. And perhaps that instinct would be right. But if we refuse to question it, we close the door to the very discoveries that might expand our history. Then come the tall tales, stories passed through rumor, fringe journals, or yellowed field reports. An iron nail in sandstone, a mechanical device in coal, a human footprint beside a trilobite. Most collapse under examination, poor records, missing samples, outright fabrication. Yet not all are born from deceit. Some came from honest eyes without the instruments to interpret what they saw. Some were simply mistakes of perspective. But even the errors carry meaning. The desire behind them, to believe we are not the first, is not foolish. It is an expression of curiosity, a refusal to accept that intelligence bloomed only once. Science demands more than wonder, but wonder is where science begins. When we imagine a civilization, we picture certain things: tools, buildings, machines, written words, monuments, and almost all of it shaped from metal. Our very model of progress is built around it. The Stone Age, the Bronze Age, the Iron Age. We measure advancement by the mastery of extraction, but that latter is not inevitable. It is simply ours. Metal is not a requirement for intelligence nor for complexity. It is only the path we took. For most of our own species' history, we lived and flourished without it. Early humans crafted stone blades, built with wood and bone, used fire, tamed animals, made clothing, painted on cave walls, and spoke languages rich with metaphor, all before ever melting a single ore. Many indigenous societies thrived for millennia with little or no metalworking, even after contact with those who did. Complexity does not begin with metallurgy. It becomes visible to archaeologists because of it. Metal endures. Wood and fiber do not. What cannot last is often forgotten. So if we imagine a pre-human or non-human civilization, one that never smelted, never mined, what would it leave behind? Almost nothing we could recognize. Organic material is transient. Wood rots. Fiber and hide decay. Bone turns to dust unless preserved by dryness, cold, or oxygen-free conditions. Textiles disintegrate. Leather dissolves. Even bone and shell vanish under pressure and time. Without ceramics, stone, or metal to anchor their memory, objects return quickly to the cycle. And once context erodes, their meaning goes with them. Picture a civilization that built from biodegradable materials: shelters of woven reeds, tools of hardwood, containers of gourds and leather, art drawn with soot, pigments, and sand. Nothing mined, nothing smelted. Every object meant to return to the earth. In the right environment, such a society could flourish for thousands of years and disappear within a single generation of neglect. A forest would grow over it in a decade. Erosion would do the rest. 1,000,000 years later, not a trace would remain. Even fire, one of the oldest technologies, leaves faint fingerprints. Charcoal, ash, heat-cracked stone, all easily mimicked by natural forces. Lightning, wildfires, volcanoes, each leaves marks nearly identical to hearths. To tell a campfire from a storm's aftermath requires context, repeated patterns, habitation, artifacts. Without them, it's only another blackened layer of soil. Some non-metal tools could survive, especially stone. But not every tool leaves a shape behind. A pebble used to grind grain, a rock for cutting meat. If not reshaped, it looks like any other stone. Only repeated use leaves polish or chipping. Without those signs, purpose vanishes. A tool without a story is just geology. It's entirely possible that a civilization could reach sophistication, agriculture, astronomy, medicine, philosophy, without ever needing heavy industry. Knowledge is not the same as infrastructure. A people could map the stars by eye, measure time with water or shadow, breed plants through observation, and calculate with string, knots, or rhythm. No forges, no smoke, no waste. Only continuity. And when continuity breaks, knowledge dies faster than bone. Language is especially fragile. Spoken words vanish with the breath that carries them. Even written ones decay. Bark, leaf, and fabric rot. Ink fades. A civilization that never carved in stone might vanish completely. It's only traced the fertile soil it once enriched. Scale matters too. Not all civilizations build cities. Some remain nomadic. Some blend into forests and reefs. Some value impermanence. Our bias is toward the monumental. We equate size with progress. But architecture, pollution, and energy use are not inevitable outcomes of intelligence. They are choices. A truly advanced culture might reject them, having seen what excess can do. It might live gently, preferring balance over conquest, resilience over permanence. And that kind of success would be archaeologically invisible. Perhaps the only evidence would be altered ecosystems. Terraced hills, diverted rivers, plants growing far from their origin, patches of enriched soil, charcoal blended with bone and pottery dust, the subtle signatures of sustainable design. Even today, traces like these exist. The dark, fertile terra preta of the Amazon, soil engineered centuries ago by forgotten hands. For generations, it was dismissed as ordinary earth. Now, it is recognized as the legacy of a complex agricultural system that reshaped entire landscapes without cities, without metal. If something similar had existed 100 million years ago, built of fiber, pigment, and air, we would never see it. It would be gone, absorbed into the cycle of life and time. Soil remembers, but it does not speak. It records what lived and died, what burned, what decayed, but it keeps those memories buried in whispers of chemistry. It does not announce what it knows. It holds, absorbs, and waits. Beneath our feet lies the meeting place between life and stone, the zone where biology becomes geology. Every falling leaf, every carcass, every root presses its trace into this thin, trembling layer. Over centuries, those traces compress into sediment. Over eons, sediment hardens into rock. But most soil never makes it that far. Rain and wind scatter it. Rivers grind it away. The record resets, again and again. That is why the stories written in dirt are always fragmentary. What survives is chance. A hearth, a patch of ash, a footprint preserved in clay, a faint shadow of habitation, a stain where a house once stood, chemical ghosts of blood or fire. And even these can vanish with a few seasons of erosion or a farmer's plow. In the scale of geological time, they are not even seconds. Researchers have learned to read these faint traces, to listen for meaning in the quiet medium of Earth. Archaeobotanists study the invisible: pollen, phytoliths, seeds, microscopic relics of vanished forests and fields. Geoarchaeologists study the chemistry of soil, the texture, color, mineral content, looking for subtle disruptions that betray human touch. A darkened layer might mark a hearth. A band of phosphate might signal habitation or waste. An unusually fertile patch might point to centuries of cultivation. But every clue requires care, for nature imitates us endlessly. High phosphate could mean a herd of animals, not a village. Charred soil might come from wildfire, not a kiln. The difference is context, and context erodes faster than any artifact. That is the heart of the problem. The deeper the history, the quieter it becomes. Even when life alters the planet profoundly, the signal weakens as it's folded back into the cycle. Fossils crush. Layers mix. Information turns to noise. And so, when we ask if others came before, the answer buried in the ground is silence. Not denial, not proof. Just the steady hum of time doing its work. Even if residues do survive, recognition is the next barrier. Could we tell an ancient garden from a wild meadow? A fire pit from a burnt patch of grass? A footpath from an animal trail? The longer the interval, the less those distinctions matter. Eventually, intention and accident look the same, and what endures is not necessarily what mattered most. Love does not fossilize. Songs leave no isotope. Belief language, and thought are invisible to geology. Even objects lose meaning. We've uncovered tools we can't identify, scripts we can't read, symbols we can't decode, and those belong to civilizations we already know existed. An unknown one would be almost impossible to recognize. That is why the silence of the earth is not empty. It is full of traces so fine we no longer have names for them. And in that fullness lies a kind of truth. Intelligence may rise and fall, but the planet's memory is short. It does not distinguish between instinct and reason, between nests and cities, between the shaping of a burrow and the shaping of a world. Everything returns to soil, and soil keeps no hierarchy. Still, even silence has tone. It tells us how fragile we are, how easily the record breaks. It tells us that permanence is not nature's promise, but our illusion. What resists survives, what cooperates disappears, and time, indifferent, carries both away. If humanity vanished tomorrow, the change would be immediate but brief. The lights would fail first, cities dimming one by one as power grids collapsed. Engines would fall silent, planes would glide to the ground, and satellites would continue their silent drift above a darkening world. For a moment, the Earth would notice. Then, as always, it would begin to reclaim. Vines through windows, rain through roofs, animals crossing highways that no longer mattered. In decades, forests would rise through concrete. In centuries, glass and steel would crumble to dust. And in a few thousand years, almost everything we built would be gone. But in geological time, a few thousand years is nothing more than a heartbeat. So what, if anything, would endure long enough to tell the story of our brief dominion? The first and clearest signal would not be architecture or art, but chemistry. Even now, the composition of the air and sea is shifting in ways that will outlast our species. Carbon dioxide levels are spiking, methane concentrations climbing, nitrogen cycles rewritten by fertilizer. These changes are global, simultaneous, and sharp, the kind of abrupt pattern that geologists recognize instantly, a sudden anomaly in an otherwise steady rhythm. If a future intelligence ever drilled an ice core through our age, they would see it glowing in the data, a vertical scar of imbalance. They would not need to know our names to know something happened, something vast and fast. Plastics would speak next, the most artificial material ever to become part of nature. They have infiltrated every layer, rivers, oceans, mountain snow, even human blood. As they break down into smaller and smaller fragments, they do not disappear. They settle, mix with dust and sand, and harden into strata. Far in the future, a thin, planet-wide layer of polymer-rich sediment may appear in the rock record, a bright, alien seam marking the moment when one species covered its world in its own design. Not indestructible, but unmistakable. A signature the planet never wrote before. We're also creating new minerals, strange, accidental compounds that nature never invented. Fly ash from coal furnaces, slag from smelters, microscopic glass from engines and explosions, concrete, ceramics, pigments, alloys, the technofossils of the Anthropocene. Buried and compressed, these will survive as anomalies, sharp-edged fragments with chemical ratios too precise to be natural. They will glitter oddly among the sandstones and shales, their geometry too clean, their composition too deliberate. If someone, or something, were to find them, they might puzzle over their symmetry. They might measure the metals and wonder, what kind of geology makes right angles? And then there is radiation, our quietest and most enduring monument. The isotopes born from weapons and reactors are unlike anything the Earth produces on its own. They decay slowly, their half-lives ticking across millennia. Even if our cities crumble, the atomic fingerprints will remain, woven into ice and bone, into coral and dust, a faint hum in the world's deep memory. To any future geologist, it will look like a momentary pulse of strangeness, a spike in radioactivity, a flash of heat, a sudden, unexplainable bloom of synthetic elements. They may never know it was us, but they will know something intelligent once disturbed the silence. Geology is the planet's diary, but it writes in pressure and heat, not ink. Its pages turn slowly, sometimes taking 1,000,000 years to form a single line. And yet through those layers of stone, the Earth remembers everything, just not in the language we speak. When scientists core through ancient seabeds or mountains, they are reading the autobiography of the planet. Each band of sediment a word, each mineral change a pause. It tells us about fire and flood, about extinction and renewal, about the rhythm of a world that endures long after its inhabitants forget themselves. If some future species were to read that record, they might find our chapter only a few millimeters thick, a narrow, erratic band of chemistry and debris, a shimmer of polymers and ash sandwiched between epochs of silence, a thin horizon of strangeness. To them, we would not be a civilization. We would be an event, a pulse of heat, a flicker of altered carbon and metal, a sudden spike in isotopes and extinction. No monuments, no names, just a signal, abrupt and brief. The Earth has seen such pulses before, volcanoes that change the air, asteroids that darken the sky, oceans that bloomed and died. It would take patience and imagination to realize that this time, the cause was not geology, but thought. Every civilization believes it will be remembered, but memory is not a guarantee. It is a negotiation with entropy. Stone erodes, metal rusts, language dissolves. What endures is transformation, not what we build, but what we change. And even that, in time, is folded back into equilibrium. Perhaps the most honest legacy we can leave is not the monument, but the awareness that permanence was never ours to claim. The planet does not grieve. It adapts. It absorbs what we were, turning us into another layer of itself. In the end, the geological record is both tomb and testament. It forgets faces but remembers pressure. It loses names but keeps the trace of breath. And if intelligence ever rises again, somewhere, somewhen, they may find that faint seam in the rock, the echo of a species that burned brightly and briefly, that learned to look back at the stars, and that asked, before fading, whether anyone had come before. In the story of the Earth, every age leaves its mark. Ash from volcanoes, shells from vanished seas, iron dust from the breath of dying stars. Somewhere between those layers there will be one more, a film so thin it could pass unnoticed, yet unlike anything before it. It will shimmer faintly under a microscope, a band of plastic and soot, of carbon out of balance, of metals once drawn and shaped by intention. To us, it was civilization. To the planet, it will be sediment. And to whatever comes next, it will be mystery. If another mind ever rises to wonder, they may touch that layer and feel it hum, a memory of warmth, of cities, of motion. They will not see faces or read words, but they might sense that once something here thought about itself. Something looked outward and inward at the same time. Something became aware that it was temporary and tried to leave a message anyway. That message is not carved in stone, nor written in light. It is the question itself, echoing still through air and soil and orbit. Were we the first to ask? Perhaps that is what defines intelligence. Not invention, not dominance, but the ability to imagine what came before, to feel the silence beneath our feet, and wonder whose footsteps faded there. Perhaps the truest monument is not the one that endures, but the one that listens. For even as we vanish, we leave behind a thin film of awareness, a bright pulse in the long dark history of the world. Our layer of light. In the middle decades of the 20th century, humanity scattered the atoms of its own invention into the sky. Tests of nuclear weapons painted the stratosphere with invisible dust, isotopes of cesium-137, plutonium-239, and others whose names sound like warnings. each particle drifted outward, falling through clouds and snow, embedding itself in soil, in rivers, in the bones of animals that had never seen the flesh. Those isotopes fade according to predictable clocks, but even now their fingerprints can still be measured in the growth rings of old trees, in polar ice, in the sediments of quiet lakes. For anyone studying the far future, that sudden radiation bloom would appear as a sharp, unnatural flare, a spike with no volcanic cause, no stellar origin, a brief, bright scar across the planet's long geological record. Our monuments, by contrast, will not last nearly so long. What we called cities, glass towers, steel frames, asphalt plains, would begin to fail almost immediately. Within decades, roofs would sag under rain, concrete would fracture from frost, iron would bloom with rust, glass would shatter under its own tension, and roots would find every crack, prying open the works of our ambition. Water, time, and vegetation would erase the geometry we once mistook for permanence. In 1,000 years, the shapes would barely be recognizable. Buried under their own debris, softened by erosion or claimed by forest and desert, only their outlines might remain beneath layers of wind-blown dust. After 10,000 years, even those hints would lie deep underground, compressed into rubble and sediment, awaiting the patient pressure that makes memory into stone. A few places might escape the surface decay, those where the earth itself would hurry to bury our remains. Floodplains, volcanic valleys, landslides, deltas. There, sudden entombment could protect fragments long enough for them to fossilize. Even so, what endured would not resemble architecture anymore. The skeletons of towers and bridges would collapse into confused piles of minerals, their purpose unreadable, their design divorced from meaning. Beneath the surface, though, some spaces could persist. The corridors carved deep into bedrock, subways, mines, bunkers, repositories of waste, might outlast everything built in sunlight. In regions where the crust is calm and the stone is dry, these sealed chambers could endure for hundreds of thousands of years. To distant excavators, they would seem alien, tunnels cut with impossible precision, lined with metals that do not belong, rooms filled with unfamiliar materials that glow faintly with ancient contamination. But without context, they would be puzzles, not histories. A server vault could be mistaken for a cave of glass. A missile silo might look like a natural void, its walls slick with strange, fused minerals. Meaning would have collapsed even if the structure had not. Our inventions, the moving things we built to extend our reach, cars, aircraft, satellites, phones, would not age gracefully. Metal corrodes. Copper turns green. Aluminum oxidizes into dust. Plastics crack and soften under heat, their polymers breaking into fragments too small to hold shape. The circuits that once pulsed with light and code would collapse into silence. A few machines might outlast us, sealed in deserts or trapped beneath landslides, engines frozen in sediment, circuit boards slowly turning into composite stone. But those would be fossils of purpose, not symbols of progress. Because nearly everything we made was designed for use, not endurance. And once purpose dies, form follows. Data, our most prized creation, would vanish even faster. Magnetic drives lose alignment in years, optical discs decay under light and time, and the electric memory of silicon cannot hold its charge forever. Every film, every book, every word that was ever digitized would evaporate into entropy. Within centuries, the sum of our knowledge would exist only as physical echoes, perhaps an etched metal plate, perhaps a carved monument. But the vast library of human thought stored in code would become unreadable noise. There is no fossil record for information. Bits do not leave bones. What we called the internet, a global nervous system woven of light and glass, would blink out long before the stones of our cities fell. Without constant care, it dies quietly. Hard drives, archives, servers, all dust and waiting. If chance preserved one of our data centers, a future species might find its racks and conduits, and wonder what purpose they served. A honeycomb of metal and cable, perhaps mistaken for a kind of mineral hive, its contents long since erased by corrosion and radiation. To them, it would be a geological curiosity, not a record of civilization. Even the written word would be fragile. Ink fades, paper rots, plastic coatings delaminate, pigments crumble. Only engravings and stone inscriptions could survive the long drift of epochs, and even those, fractured and scattered, would be unreadable without the language that once gave them voice. Our digital empire, this web of pixels and pulses, would not leave a monument. It would leave an absence, a silence within the strata, a chemical gap where something bright once moved, a blank interval in the rock that marks an age of noise now gone still. Agriculture might outlast our monuments. Its fingerprints are etched into the planet's skin, reshaped rivers, terraced hillsides, cleared forests, endless grids of monoculture. These transformations altered erosion, rewrote the chemistry of soil, and even changed the DNA of plants. Millennia from now, fossilized pollen might still whisper of this age, traces of a few species dominating where once there were thousands. A sudden narrowing of diversity would mark the arrival of human design. Beneath ancient mud, patterns of carbon might tell the same story. Dark streaks in the strata where forest once stood, followed by pale bands where fields spread in their place. Future botanists could reconstruct the rhythm of cultivation, the rise and fall of harvests that no one remembers. But they would never know the farmers nor the hunger and hope that shaped each furrow. They would see only the echo of order imposed upon chaos, and then abandoned to time. Our animals would leave bones too. Clusters of domesticated species, dogs, cattle, pigs, sheep, their remains gathered near the ruins of long-forgotten settlements, each skeleton carrying genetic marks of intervention, the subtle sculpting of evolution by will. In some layers, chemical residues would speak softly of the age of antibiotics, molecules preserved in sediment, tiny signatures of an artificial immunity. If buried quickly, some of these bones might persist for tens of thousands of years, outlasting every written word about the creatures they once were. And then there are the deeper marks, the ones carved into the planet's metabolism itself. Our harvest of fossil fuels has altered not just the air, but the rock and water. Every fire we've lit with oil and coal has released carbon from ancient seas back into the wind. That breath of combustion, a billion years of sunlight burned in a single century, now leaves its trace in limestone, ice, and shell. Far in the future, a geologist might find a narrow, dark band of stone, its chemistry spiked with carbon isotopes that don't belong there. Compressed into a few centimeters of rock, it will tell of a planet that warmed too quickly, of oceans that grew sour, of a sudden planetary imbalance. To whoever studies that layer, it will look like a short, violent fever in the planet's long, calm pulse, a flare of activity that came and went too fast to be natural. It will be the unmistakable fingerprint of us. So what would endure when we are gone? Not our monuments, not our words, not the fleeting architectures of ambition, but the chemistry of our passing. Ratios of isotopes, synthetic molecules, traces of heavy metals and altered stone. A sudden spike in carbon, a thinning of biodiversity, a planetary signature too sharp and too synchronized to be mistaken for chance. Some future intelligence, human or otherwise, could read that signature like a heartbeat frozen in rock. They might find a narrow band within the crust where everything changes at once, a bloom of plastics and glass, a drop in species variety, a film of ash and radiation. It would be our autobiography, written in elements rather than words. To them, it would say, something intelligent lived here. Something that built and burned, that extracted and buried, that altered the planet's balance and then vanished into its own debris. The evidence would not tell our stories, but it would confirm our existence. A civilization that flared bright enough to scar the world's timeline. And perhaps, For whoever comes after, that scar would be enough. Enough to recognize that once, thought itself had taken physical form. Enough to know that self-awareness, for a brief time, left fingerprints on the very face of the earth. They might not understand what we were, or why we ended, but they would know that we were here, and maybe quietly they would wonder what became of us. Now let's turn the mirror around. If we will one day be only a thin chemical scar upon the planet, what if another intelligence once was, millions or even tens of millions of years ago? If they lived, built, and vanished before our time, then where is their layer in the stone? If the silence of the earth isn't proof of absence but evidence of erasure, what would it take to leave no trace at all? And how likely is it that someone already has? Imagine a civilization that rose long before ours, their cities drowned beneath ancient seas, their machines crushed under the weight of mountains, their memory swallowed by time itself. If such beings existed, the question isn't what they were like, but why not a single whisper of them remains. The Earth is not a patient archivist. It is a restless one, an author that constantly rewrites its own pages. Tectonic plates drift and grind, carrying continents into the mantle, where rock melts and memory liquefies. Erosion wears down mountains and sweeps the dust across oceans. Forests rise and fall. Deserts shift their borders. Rivers redraw the same story again and again on new parchment. Even without disaster, the simple motion of the planet is enough to erase. Stone becomes sand. Sand becomes stone again. And with each cycle, the old inscriptions disappear. Given enough time, almost everything a civilization could build would be swallowed, folded, and forgotten. No apocalypse is required, only patience. For the Earth, destruction is not an act of violence, it's the continuation of its breathing. Yet the vanishing of structures is only half the mystery. What truly fades is not material, but meaning. It isn't just the ruins that dissolve, it's the story behind them. Because even if an earlier intelligence once walked this world, why is there no echo of them in our myths? No genetic memory? No faint line of inheritance running through the ages? If they existed, why do we not remember? Did they perish, transcend, or simply fade away so quietly that history never noticed their absence? Human civilization, by comparison, is barely a flicker. A few thousand years of agriculture, a few hundred of industry, a handful of decades of data. And in that blink, we have already reshaped the planet. Now imagine another species that did the same, 50 million years before we appeared. What would remain of them? At best, a few centimeters of altered sediment. At worst, nothing at all. We like to think that intelligence is cumulative, that once awareness sparks, it inevitably grows, layer upon layer toward permanence. But evolution owes no loyalty to progress. Species vanish in a season. Cultures collapse in a single drought. Complexity is not a shield against entropy. Perhaps they ended suddenly. A war, a climate shift, a runaway invention. Or perhaps their decline was slow, almost gentle, soil exhausted, ecosystems unbalanced, connections too interwoven to endure. They might have dwindled, scattered, their knowledge fading into superstition, their language unraveling into silence. Or maybe they didn't fall at all. Maybe they chose to withdraw, to stop expanding, stop consuming, to turn inward instead of outward. A civilization that learned restraint might have blended back into nature, deliberately erasing its footprint until no trace remained but harmony. Not a collapse, a surrender, a quiet decision to vanish on purpose. If so, they might have done it so completely that we could walk through their graves and never know. There is a darker possibility, that they never lived long enough to leave a memory. That intelligence flared for a moment, bright, fragile, and brief, but never reached the threshold of permanence. Not every spark becomes a flame. A species might awaken, discover its own mind, and then vanish before that awareness could anchor itself. A single storm, a disease, a shift in climate, a predator learning a new trick. Any one of these could snuff out consciousness before it learned to name itself. Maybe thought bloomed here more than once. Maybe it took root in shapes we would not recognize. Not bipeds, not builders, but oceanic minds, forest networks, colonies of thought without faces or bones. Intelligence might have worn 1,000 forms before one of them happened to walk upright and hold fire. And if so, then our idea of civilization may simply be too narrow to see theirs. They may have spoken through patterns, not sound. They may have built with wind, not stone. They may have recorded in genes instead of ink. If we cannot imagine their tools, we cannot hope to find their ruins. Perhaps they never left this world at all. Perhaps they were folded back into it, their knowledge rewritten into the DNA of the living, their atoms scattered through the same soil that now grows our food, their technology melted into the elements we mine. Maybe we have already unearthed their cities and crushed them into gravel, smelted their monuments into metal, burned their libraries for fuel. It could be that their traces are everywhere, just too blended, too altered, too well digested by time to notice. Perhaps the silicon in our chips once lay in the walls of their own machines. Perhaps the minerals in our bones once formed the skeletons of beings who dreamed before us. And maybe, in a way, they never left. Not alive, not sentient, but embedded in the systems they created. Ecosystems reshaped, rivers redirected, genes modified in ways we now call natural. Their legacy might survive not as artifact, but as pattern. A ripple still passing through the world long after the hand that made it disappeared. The deeper we dig, the more we learn that endings are rarely noisy. Loss does not always announce itself. Sometimes it arrives softly, folding one story into another until both are indistinguishable. Now comes the harder question. Even if we did uncover the signs of a lost civilization, would we recognize them? Would we believe what we were seeing? Knowledge is not just a matter of data. It's a matter of perception, of what we are willing to accept as real. For the greatest obstacle to rediscovery is not the absence of proof, but the blindness of expectation. Science does not demand humility, but the universe enforces it all the same. Every time we've declared ourselves central, the cosmos has moved us outward. First from the earth, then from the sun, then from any special place at all. Now, as we peer backward into the depths of our own planet's memory, we face another quiet demotion. The possibility that awareness may have risen here before and vanished without a trace. This thought doesn't insist that we were not the first, only that we cannot know for sure. It's a lesson in proportion, a reminder that the silence of the past does not mean emptiness. We like to imagine intelligence as a singular event, a miracle, a first spark. But perhaps it's more like lightning, recurring, unpredictable, striking the same ground again and again across ages too vast to measure. The absence of evidence is not evidence of absence. Time erases with precision, and the earth is an expert in forgetting. Its layers close over every trace until what was once fact becomes myth, and myth becomes nothing at all. If others did come before us, we might walk upon their graves every day and never realize. And that is where humility returns, not as surrender, but as honesty. We have to admit what we do not know, and accept that some truths may forever remain beyond reach. Perhaps we are the first, perhaps not. We may never prove either, and even if evidence did exist, we might never see it for what it is. Even now, as we map anomalies, trace isotopes through stone, and measure strange chemical patterns in the deep record, we are guided and confined by what we expect to find. A buried city that we'd understand? A sudden spike of iridium? We'd call it a meteor. A layer darkened by carbon? We'd name it fire or decay. But what if it were none of those? What if it were something entirely unfamiliar? Something no one had ever been trained to see? Recognition is a fragile art. We see meaning only where our minds are prepared to see it. Our instruments read data, but our beliefs decide what that data means. Even science, the most rigorous of our tools, is shaped by imagination. It draws its power from curiosity, but it also inherits our limits, our tendency to pattern the unknown into something we already understand. So when the Earth whispers of anomalies, we often explain them away, not out of arrogance, but out of discipline. Because extraordinary claims demand extraordinary proof, and the record of stone rarely offers any. We search for relics that declare themselves, structures, languages, tools, and dismiss everything else as background noise. But perhaps the signal we seek has always been subtle, woven through the very noise we ignore. In that sense, the great forgetting of the world may not be nature's doing alone. It may be ours, a blindness born not of ignorance, but of expectation. This limitation isn't only scientific, it's emotional, cultural. Because if we truly accepted that something like us once existed and vanished, it would unsettle the story we tell about ourselves. It would strip away the illusion of inevitability, the comforting idea that progress always marches forward. If others reach the same height and fell, then our civilization is not a destiny. It's a moment, a fragile bloom in the long garden of time. It could fade as easily as it appeared. To imagine predecessors is to confront our own impermanence. It means that intelligence is not a crown, but a chance. A rare alignment of chaos that can happen and then stop happening. It means that our monuments, our data, our memories, all of it could dissolve into sediment just as theirs did, until only chemistry remains to testify that we ever lived. And maybe that's why the idea feels so heavy. It's not the loss of mystery that frightens us. It's the loss of meaning. If someone built and dreamed before us, what does that make us now? Their echoes? Their replacements? Their mistake? Would we see ourselves as continuation, or as proof that nothing truly lasts? These questions don't fit neatly into laboratories or journals. They belong to the deeper human spaces, to philosophy, to art, to the quiet moments before sleep, when the boundaries between science and wonder blur. But still, they matter, because the act of asking changes the shape of our curiosity. It reminds us that discovery is never finished, that certainty is a comfort, not a law. So we dig, and we measure, and we doubt. But beneath all of it runs the same quiet truth. We are limited not only by what exists, but by what we expect to exist. The absence of evidence is not the evidence of absence. It may simply mean that the Earth, patient and relentless, has done what it always does best: forget. And so humility circles back again, not as defeat, but as balance. It steadies us when the light of certainty fades. It asks us to stay curious without demanding resolution. We do not know if we were the first, and that ignorance is honest. It may be the truest knowledge we possess. Perhaps we will never find proof. Perhaps proof has never been the point. The search itself, the act of asking, is what connects us to every mind that ever wondered before. If another intelligence once walked this same ground, looked at the same stars, felt the same awe, then even in silence, we are not alone. The absence of their voices does not mean they never spoke. It may only mean that their language has become the wind itself, a pattern too vast for us to hear. Science teaches caution, but humility teaches perspective. They are not enemies. They are partners in the same pursuit. One measures the world, the other measures our place within it. And perhaps that is enough. Perhaps the purpose of the question is not to uncover an answer, but to remind us that knowing and not knowing are both parts of being alive. The idea that intelligence may rise again and again, that awareness is not unique, but cyclical, is not a threat to our significance. It's a deepening of it. It means that consciousness is not an accident. It is a rhythm, a heartbeat the universe keeps rediscovering in new forms, in new faces, in new times. We may be one verse in that endless song, or the first, or the last, and the truth is, we might never know either way. This is the humbling possibility, that intelligence is not ours alone, that it has flickered across the ages like starlight, appearing and fading again and again on this same ancient stage. Perhaps it has lived and died 100 times in forms we could not imagine, each time believing itself to be the first, each time leaving behind only a whisper. We want to believe that if something so great had happened, we would know. That the earth would have kept the record safe for us. But the world does not preserve, it renews, it devours what it creates, folding memory into mineral and mineral back into dust. Most of human history, even our own, is already gone. Empires that ruled continents have vanished into a handful of artifacts and broken names. Entire languages have fallen silent, their words ground into the soil that grows our food. If 10,000 years can erase so much, what could 10 million do? The geological record is not a chronicle. It's a puzzle missing most of its pieces with no image on the box to guide us. We find fragments, black against white, jagged against smooth, and try to make them speak. But for every story we piece together, 1,000 more have already turned to stone. So we reach the edge of certainty and look beyond it. Not with faith, but with attention. Because the silence of deep time is not proof that nothing happened. It's simply the sound of the planet thinking slowly. Our instruments listen for patterns, but meaning requires imagination. We know what cities look like. We know what bones look like. But we don't yet know what forgotten consciousness looks like when pressed into rock. Maybe we've already found it. In data mislabeled as anomaly, in stones mistaken for ordinary. Maybe we've walked over their ruins, dismissing their legacy as nothing more than strange coincidence. And yet, the act of asking changes everything. It stretches our sense of time, loosens our grip on certainty, and reminds us that awareness is not an endpoint, but a fragile alignment between memory and matter. If someone came before us, what would that make us? A continuation? A correction? A repetition of the same pattern, rising and falling until the earth grows quiet again? We don't know. We may never know. But perhaps that is the beauty of it. Perhaps the truest legacy of any civilization, past or future, is the question itself. Because every time a mind looks backward and wonders if it was alone, something of that earlier mind stirs. Not in words, but in the shared curiosity that spans all who have ever thought. The past is not fixed. It shifts with every new gaze, every new question, every spark of imagination that refuses to rest. So let the mystery remain. Not every silence demands an answer. Some only ask to be heard. And now, at the edge of all our wondering, there is quiet again. The kind that comes not from ignorance, but from awe. You've walked through the layers of time, through questions older than language, and you've carried them far enough for one night. So rest now. The earth will keep turning. The stories will wait. And whatever came before, whatever may come after, you are here, now, breathing in this brief, luminous moment between eternities.